Thank you, Nate. So let's start a little bit with getting to know you a bit before we start. How many of you are here for the first pre-day? 1, 2, okay. Some hands, left, right. All right. Second pre-day? Third or more? All right, some Microsoft people in the room. All right. So it seems like most of you are here, majorly for kind of the first time or close to it. My name is Josh Palma. I'm the Principal PM Lead for AKS. And throughout the day, we're going to be discussing a lot of what we've been working on, a lot of also what's coming, and discussing a little bit of the overview on AKS. As Nate said, in the afternoon, you also have the time to get a bit your hands on the actual product. And whether you're kind of a novice or already fairly experienced with AKS, you can do an advanced or an initiate lab to get to know the product. Speaking of which, who here is already using AKS today? Love you all. Who here has never used AKS? Love you all too. Let's get going with that. So for those of you specifically that maybe don't know AKS, what is it and what does it do? So AKS is a managed Kubernetes platform, of course, and one of our key tenets and key principles is that we want to have fully managed operations. So we want to make sure that everything that we do and every component from the service is fully managed. So from the add-ons, DNS, metrics, everything is completely managed. We take care of the life cycle, patching. We manage all operations that you might need to do, and we automate all of them as well. Furthermore, we want to make sure that we provide and we try to take over as many operations and as many tasks that are not incumbent to your business logic, to just progressing whatever it is that your goals are. The second thing is we want to make sure that from a developer perspective, you're able to have a very productive life, whether you are bare bones on top of Kubernetes or on top of a platform that resides on top of AKS. We want to make sure that you're productive, and we want to provide integration with CI/CD, be it with GitHub or Azure DevOps. And of course, you can choose any other of the options there. One of the things that we want to do is want to be opinionated in everything that we offer. So provide you with an opinion, provide you with a golden path with what we believe is the best practice or something integrated into the Microsoft ecosystem. But at the same time, make sure that you have an option to use whatever tools you prefer and can bring from the ecosystem as well. We also want to make sure that we have a service that is mission critical ready. You'll see some examples throughout the day of why that's so important for us. So we want to make sure that the reliability of the platform and also the reliability you can achieve for your workloads is top notch, and that you have all the right controls and all the right SLAs that you might need for them as well. Furthermore, AKS is what we call at Microsoft a Ring 0 service. So that means it's present everywhere that Azure is present, and everywhere that Microsoft is typically present. So some edge locations as well as you can deploy it yourself into your own edge compute too. And because of this, and as you start to grow from a single cluster with all that goodness into multiple clusters, we want to make sure it doesn't become a burden. We want to ensure that you have the simplicity of managing that fleet of clusters the same way that you would manage one, or the simplicity of 1,000 clusters kind of boil down to what would be 10 or even 1 as well. So we have a lot of fleet management capabilities, and we'll see some of them as well today, for multi-cluster and multi-region to simplify your life there. The second row there is we want to make sure that you can go to the moon in terms of elasticity, that you are able to, for whatever kind of workload and whatever their needs are, be it retail on Black Friday, be it some risk analysis type of workload that needs very burstable scale, be it a very kind of much more soft in terms of scale but very mission critical type of internal application, you have all those capabilities there for you. And you're able to achieve those without breaking the bank. So achieving those with all the optimization capabilities and visualization and cost management abilities that you might need. One of the key things for all of you that are already working with Kubernetes and even with AKS is that most Kubernetes systems still require an upgrade. Maybe there's a future. I mean, we're at KubeCon and they continue to exist also exactly to push those boundaries forward. Maybe upgrades will disappear one day, but we don't see that future that close. So until then, this is one of the key areas that we have been investing a lot on to ensure you have all the controls to have, be it blue-green upgrades or very granular controls across the operations, and also have them fully automated, integrated with your own metrics, and with the right settings so that you can achieve them without downtime. And of course, to do that, you need a first-class observability suite, be it one that you bring in, but also we have one fully integrated across all layers of the observability stack in Azure with our Azure Monitor suite based on Prometheus and Grafana, of course, but also with OTel integration across the board for traces. All right, final row, and this very busy slide will be over with. Then we can actually go into demos. Security. You might have noticed several blogs from Microsoft over recent times calling out our Secure Future initiative. That's been a lot of efforts that Microsoft as a company has put in advancing security and ensuring that all our internal customers, which a lot of them, the majority, run on AKS, but also all of you, our users, have both access to security and have it at your fingertips very easily and built in. We have over hundreds of controls for security in AKS to achieve all kinds of standards and compliance regulations that you might be subject to. We'll see a lot of those later on today, and it's just a fraction of the actual total number of them. And when it continue, it's a never-ending journey to continue to secure, to continue to find a new vulnerability or a new exploit or a new way to just be better, be easier with regards to security, to not have those compromises that maybe security brings some complexity to the system. Try to continue to smooth those things out. Then it goes to your workloads, right? Which is ensure that we leverage the best that Kubernetes gives us with self-healing and probes and everything that Kubernetes already provides, but also resilience mechanisms that you can leverage from Azure and from the ecosystem, from backup to chaos testing, to a lot of our persistent storage, to a lot of our hosted databases that you can leverage, and a lot of the same systems that you can integrate with AKS very easily with things like Service Connector. And then finally, something that we could not leave this slide with, I mentioned it several times, and I'll mention it one last time, which is we provide all these things, but at the end, we want to make sure that the choice is with you. We will provide you our opinion, and we'll provide you a path. But in the end, this is vanilla Kubernetes. We have no intention to ever change that. And we want to make sure that everything that you run anywhere, you can run it on AKS, and vice versa. Every solution that we build, we want to make sure it can run everywhere, based on open source and contributing to a solution that can work in any Kubernetes cluster. All right. So hopefully, this is a lot of talking. Let's jump to a demo that actually shows what is it that I just described. So what exactly does AKS look like? Maybe some of you have already played with a lot of the capabilities I'm talking about. Most of what I'm showing today right here already exists. So it's a good time for a lot of you to catch up. And for those of you that have not tested AKS, this is a good way to get familiar with the product. What you see here is a deploy application screen in the Azure portal that will allow you to start exactly from code, whether you have an AKS cluster already or not, so for everybody in the room, and allow you to deploy an application. So let's take a look. So we're going to select a resource group as usual to see where exactly we're going to put the metadata. And now we're going to select a repository, namely a GitHub repository in this case. It could also be Azure DevOps, and the respective branch for that repository. This is going to be very important because, again, we might or might not have a cluster, and in this case, we already have an app. Now, from this app, you might see right there, we're automatically generating the Docker file. So this app is not containerized at all, and so we're automatically creating Docker files for this application. It detects that it's Node.js, detects that it's JavaScript, and it creates a Docker file for it. And we're also just creating a container registry to host that image once we build it and push it to that registry. In regards to the deployment manifest, again, most of you are using Kubernetes, so you know you need YAML, you need deployment services. This can create them for you. And not just any YAMLs, but YAMLs following all best practices, from deployments leveraging probes to leveraging PDBs to things that are auto-scaling automatically and more. And now you can see that, again, either you have a cluster already today, and you can point this to your existing cluster, it doesn't matter which cluster, by the way, or if you want to create a new, one of the brand new AKS automatic clusters, you can select that option, give it a name, and move on. But again, we're not just here doing click ops. I wouldn't do that to you. So we actually are generating all of those code files, all of those manifests, and we're putting it back into the repo that we configured. And the way to deploy all of this, cluster included, is to merge the pull request with all of those files. So you can see all of the things that I mentioned there. And once you merge this pull request, in this case a GitHub action, which is what we chose, could also be a pipeline, is going to deploy all of this into the cluster. And from there, any iteration to your application, you'll be able to merge and get it automatically deployed into the cluster. So this not only created all those files for you, but it also allowed you to have a pipeline and a CI/CD immediately created for you and have an application really quickly deployed, whether you had a cluster or not right away. Furthermore, whether you're an expert and already had very intricate knowledge of what pod disruption budgets are, what health probes and be it readiness or liveness probes are and all of that, you can set those up and you can already use your manifest. You already have Docker files, you can use them and select them, or you can allow the tool to create them for you. So let's maybe take a look at, we started, promise. So let's take a look at what this actual application looked like after we deployed it. So we can jump into our cluster that we just did here, our Contoso Air cluster. But before we actually see the application, this application specifically needs a database. And I could deploy something like a MongoDB in this cluster, but instead I'm actually going to show you how to very quickly leverage a Cosmos DB in Azure and immediately connect it to the deployment that we just did. And I'm going to leverage Service Connector for that. So in here, I select that I'm using workload identity. I select the identity that my application will use to authenticate to this Cosmos DB. And we'll create a connection for this Cosmos DB database. And now for all of you, again, that have done this, you know there's a step missing, right? Okay, you created a Cosmos DB, you give it permissions, identity, all that. But where are you connecting it to my application? So for that, you need to know things like either connection strings, or maybe you're using something like workload identity, which is the case, and you need to load in a service account into your deployment with the right environment variables. So that's a step that, again, you might know or not know. So Service Connector will help you do it. So it will tell you exactly where in your deployment, you can select your deployment specifically, so our Contoso Air, and it will tell you exactly where to put those new fields. And you can also just go on and merge this back into your flow and get this deployed as well. So once this is all done, your database is created, identity is created, workload identity and service account is loaded into your deployment, and we could go into it and finally access it. We can continue this, and this is it. This is Contoso Air, really, really quickly done. So it's a website that takes care of flights and vacations. Doesn't work, don't try it. But now we could continue, and there's much more that I could show you. We could stay here for a long time. We could go into ingresses and how we're making it simple for you to have secure kind of connections with things like application routing and more. And it makes it very, very simple for you to have TLS, for you to have DNS, certificates, etc. And there's a lot of demos about that we shared. We're going to share some more as well at Ignite, which is next week. So keep an eye on that. But for today, I would actually like to go into a little bit of a different direction, which is if we have this application deployed, assuming that you all start to hit that IP that I already asked you not to do, and I know some of you are, regardless, what will happen if that you start hitting it a lot of you start to hit that IP, we need it to scale. And so this cluster was set up with Azure Monitor, and Azure Monitor has, as I mentioned, a Managed Prometheus and Managed Grafana type of option. This is what you're looking at right here. So our container insights with our manage Prometheus and manage Grafana. And we're going to set up and we're going to collect metrics and scrape metrics from this application. So for that, we're going to use our service monitor and a CRD here that will look at our ContosoAir and scrape from the /metrics all our good HTTP metrics that we want. Then we're going to use SCADA, our Kubernetes Event-Driven Autoscaler, which is an add-on in AKS that you can leverage. And we're going to use this Prometheus endpoint and a simple query on HTTP requests to scale based on the number of HTTP requests that this website takes, for example, at peak. Furthermore, we can turn on vertical pod autoscaler because even though our automatic deployment selected some limits and resources for it, because I told you it follows best practices, it might not have been the correct ones. And so vertical pod autoscaler will look at it historically and define them. And now we're going to test it. So on the left, you actually have load testing using Hey, a simple CLI tool. And in the middle, you see that there's 2D, 2LS VMs, so 2 core VMs. And now you already see a bunch of pods that KDA is scaling that don't fit on those D2L. And you already see a D8 that got spun up immediately for all these pods. That's Carpenter and node auto provision in action, provisioning the capacity that you need just in time exactly for the deployment that you did here. And if we jump back into Grafana, you'll see a bunch of dashboards that I couldn't begin to understand how to set up that are there automatically for you, loaded from the start, built in. So you can already use them as is the moment you turn on Manage Grafana. All right, so what about availability, right? So you want to make sure that you deploy, as I mentioned, pod disruption budgets if you didn't. So in this case, we already did. What about if we want to go even further? So what if we want to, for example, go into make sure that our zonal settings are correct? So you might leverage our zone topology keys and our topology spread constraints to ensure that our ContosoAir is deployed across our zone. And now, if you look at it, there's a 2 and 3 zones in our VMs, but we actually want 3 zones. So you'll see another VM in the 3rd zone being deployed for that as well. Simple enough, right? But fairly powerful. What if one of these zones goes down? So you see we have our 3 pods, our 3 VMs in our 3 zones. Everything is happy. What happens if one of these goes down? And how do you even test that? So that's where, again, those integrations really pop in. In AKS and Azure, you have Azure Chaos Studio that allows you to very easily run experiments, which are failure experiments, in a Kubernetes cluster. Chaos Studio allows you to run all kinds of experiments on infrastructure, and then it integrates with an open source project called Chaos Mesh that allows you to run a number of experiments in Kubernetes as well, from simulating policies to simulating stress on pods to blocking traffic within it, all kinds of things. And then you can also leverage it on the Azure infrastructure side to do things like I'm going to do here, which is just a very simple and naive VM shutdown. So I'm going to simulate by shutting down the VMs in 2 of those zones that they're going to go down. Now, this is not actually down in terms of the zone. So what do you think is going to happen when I shut them down? So Carpenter and node auto provision that is in that cluster should basically get those pods, still requiring those zones, ideally. And it will see, actually, I'm fine. I could just provision another VM in those zones, and it will do just that. But if those zones would actually down, it will notice that it can't get VMs in that zone. It will get a new VM in one of the existing zones, and the workloads will flow there. So we finish our experiment here in Chaos Studio. We review and create it. And let's actually see that simulation in action. So let's kick it off. So after you set it up, you can start it. So you can reuse it as many times as you want. You can simulate it as many times as you want. We internally, we run these kind of drills as well ourselves. And so what you're going to see here, and look at the bottom in this case, and you're going to start to see some not readies pop up, which is those VMs going down. But look also, and look at the 9GR, right? So memorize that, 9GR. That's already going. So you have an 8GL. So those VMs were immediately replaced as Carpenter detected that the pods were pending. It could still deploy VMs in the zones that were down, and it just provisioned new VMs, in this case exactly like the ones before. Again, very simple. This is exactly what you want from a resilient service, from a reliable service, and that ideally does this without you even knowing, which is the case here as well. And now, of course, upgrades, right? The typical scary beast. So I'm going to go in, and I'm going to upgrade this cluster from 1.28 to 1.29. And one of the key things that we did in AKS has been very, very popular, really, really happy about this functionality, is the fact that it automatically detects for any deprecated APIs. Okay, this already died too fast. It already detects for any deprecated APIs that this cluster was calling, be it an operator inside the cluster or a client or anything that is calling those APIs. So it will stop the upgrade automatically, and it will also allow you to go into diagnose and solve and know exactly which client, which user agent, at which timestamp, which verb was it calling. So you can go into the specific app team, for example, and say, hey, your application, your operator is using deprecated APIs, and I can't upgrade the cluster, otherwise they will break. So they can very easily just turn that off, change it, and that will be solved. So because of all these reasons, and the slides were really insistent on me telling you this, a lot of our users and a lot of you are already using AKS. As I said, we love all of you. And leveraging all of these benefits. Not just from the folks here, we also have what seems like an army, at least from here, of Microsoft people in the room, which also include a lot of our first-party users inside of Microsoft that use AKS. So as I mentioned before, inside of Microsoft, we use AKS extensively across our product portfolio. A lot of our AI investments, from Teams meeting recaps to the GitHub control plane, Copilot control plane, to the Bing chats, to even OpenAI itself and ChatGPT runs on AKS. And that has really, really pushed us into new frontiers. Same as all of you as well, and all the folks in that previous slide as well. And so, not just from a scale perspective, but also pushing the boundaries of what we should be doing for you, pushing the boundaries of reliability, pushing the boundaries of performance. And that's exactly what we want. We want to continue to do more, and we want to continue to push things forward. But before we go there, I would like to essentially let you hear from one of our users. This is Victoria's Secret, and I'll let them tell their story for you.
Victoria's Secret digital platform is powered by state-of-the-art commerce engine.
People are coming to Victoria's Secret mainly to purchase the lingerie product. That's what we are so proud of.
As with every organization, we have this classic problem of managing infrastructure, which is not our core competency.
Our primary focus was how we can able to make the website available for the business to scale. We're also looking for agility and innovation, and looking for how we can improve those efficiencies.
We have seasonality, which brings in volumes close to 20x times than what we see during a normal day. This is a classic retail problem.
Either it could be for the Valentine's Day, or it could be for Thanksgiving or Cyber Monday.
Going to Azure Kubernetes service, the decision was very straightforward. We were able to bring in that auto-scaling.
The technology platform provides the flexibility for us to test and validate, and then see how we can able to leverage in terms of improving the performance for the customers.
Before we moved into Azure ecosystem deploying, we were doing 9 releases per year.
The team can able to release 30 to 50 features in a month. That is critical for us.
We completed the entire migration in 6 months. And right on the heels of it, we handled the entire holiday season from Azure Kubernetes service. For customers, response times have gone down.
Moving from a landing page to the product page to the add to bag and checkout, if the customer can able to do all of them in a faster pace, in a shorter time period, means you got the win.
Our site used to take 6 to 8 seconds to load a page. Now we are talking about 2 to 3 seconds. That is a 3x performance improvement. TFD is a direct reflection of revenue gain for us. We have redefined and re-architected.
The platform is right now, it's much nimble and scalable. So I can say my cost went down and my performance showed up. I'm like, that's a typical graph anybody wants to see, and then we saw that.
Microsoft has been a great partner for Victoria's Secret.
I think the successful partnership is, again, it's always the people. I think people makes a difference in my opinion. So the Microsoft team are the perfect combination. The more and more Microsoft bring new capabilities to make life easier and customer life easier, that's what we need.
Okay, always kind of jumps to Mike out of the 2 data points there on 9 releases a year to 30 features a month and the 6 months migration. Of course, that goes through a lot of different areas and not just AKS itself, to the processes that they adopted as they moved into cloud native, kind of a whole bundle package. So this brings us, we kind of walked into the today and the present and what's there already. Let's take a bit of a sneak peek into the future. I think that's what a lot of you are here for. So in AKS, there's 2 key things that are our guardrails, our guiding principles. And the first thing, I already mentioned it to you, which is ensure that everything that we build is rooted in open source technologies, whether they already exist and we're contributing and adopting to them, or whether they don't exist and we're creating a new project and donating it. Several of them being donated right now during this week and announced as well. The second thing, right at the top, is ensuring that everything is deeply integrated into the Azure and Microsoft ecosystem, so you have the best and easiest experience. And by design, these are 2 things that we want to be at odds, and we want them to be a forcing function to each other, because we don't want them to be a trade-off. So we want those integrations, such as Azure Policy Integration, to, yes, be there so you can very easily apply policy to all your resources, be it VMs or databases, as well as AKS and containers, and have that solution be built at the top of Gatekeeper and OPA, fully open source solutions that you can leverage in any cluster anywhere. And so, what is next for us then? What kind of areas of investment, and at the same time, what kind of things are we hearing from you that are driving those areas of investment? What problem areas have you been telling us that are painful for you and that we're working on right now and for the next 6 months? So the first one respects to capacity. It's really frustrating as you go into the cloud, where you have this kind of infinite scale capabilities, if you then actually don't get that. It's kind of going around the world and then finding out that you can fall off over the edge. It doesn't make any sense. Why is that even happening? And a lot of times this is because of rigidness of how the node pools are, where you're stuck into a specific SKU, or rigidness in how you actually can adopt new families and the limitations of that, where you are tied with specific things to a region or your application or your data. And so we actually want to make sure that we can do more there for you, that we resolve a lot of those issues, and that we really provide you with flexible and elastic capacity that goes around all of those things, so you can have that infinite scale in the cloud. Second is proactive workload resiliency, which is, of course, I mentioned already, kind of all the efforts we're doing in terms of platform reliability, as well as the controls we offer for resiliency. We want to do even more. We don't want to leave your workloads and your workloads' service level objectives and availability and performance to your responsibility alone. So we want to assist you as much as possible with that. We want to do our part. We want to make sure the platform is resilient, is reliable, offers all the controls, but then we also want to assist, as you just saw before, by having tools that automatically generate manifests that follow the best practices, that have all the right availability controls and knobs built into it, that have the right auto-scaling, the right balancing when zones are there, and make the right choices for you when no one is looking. So we want to do that proactive workload resiliency. The third is, and I talked to you about it, right? We have so many security controls. What else are we doing in security? Well, there's 2 areas, right? First of all, it's a never-ending job. It never finishes. But second, we really want to provide it in an effortless way. And these are some of the key tenets that we have in our Secure Future initiative is making security a lot easier for you and making it built-in, making it default, and removing any trade-off that might come with it so that it doesn't have to be painful, it doesn't have to be complex to be secure, and it's just there for you. Next, we have ensuring that you can leverage and kind of ride a bit on this AI wave that seemingly everyone is talking about, we primarily. If you haven't heard us talk about AI, I don't know where you've been. So there's a lot that you can leverage there. We have a lot of AI services. We have a lot of tools. We have a lot of ways to run AI in Kubernetes. We want to make sure that you have all the productivity tools, you have all the right controls, and you have all the right add-ons and services to enable you to infuse AI into your applications and easily build already AI and intelligent applications. We're going to continue to push those boundaries forward. You saw some of the names there before on the slide. You saw some of our internals. Some of you, I'm sure, have scenarios that are trying to push the boundaries even further. We love that. Let's go. Let's do it. So if you have something that wants to go to where no one has ever gone before in terms of Kubernetes scale, Papniti is right there. You know, there's a performance and scale table. Sit down at lunch, tell them where you want to go, and we'll get there. So we definitely want to go even further in terms of performance and scalability. And then finally, we want to make sure that that cost optimization and those controls that we provide, that visibility that we already provide, that's really nice, but we want to make that automatic. Once again, we want to make that built-in and default. We want to ensure that you are optimized right as you start, instead of that being kind of an afterthought that you need to do after you architect and after you do all these things. Then you look at the bill and you're like, is this really the cost that I should be paying? And then you go and you optimize and you find out all the ways that you could be saving. So we want that to actually be automatic. And we want that to be more transparent. So we want you to know that even before you finish that architecture and are able to do that yourself easily. All right, so this now, of course, will take us the whole week. Lock the doors, you're not going anywhere. We're going to go into all of these topics, which is impossible. We have lives to live. KubeCon is the rest of the week. So we had to scope some of these down. But good news is, we're actually going to touch some of these at next week at Ignite. So, for example, cost, we're going to cover next week at Ignite in our scale, secure, and optimize AKS session at Ignite next week. So tune in for that one. Even if you're not going to Chicago, you can watch online for free. And with regards to dev and build intelligent applications and increasing your dev productivity, we have a full morning on it on the next KubeCon, which is in India in a month from now. And once again, like today, we're recording, and you can watch all those sessions as well. All of them are in our AKS community at aka.ms/AKS/community, such as this one. So if I talk too fast, or if you missed something, you're going to be able to find everything right there. And we would like to ask you, what else would you like to do? So of course, we're not going to be able to go into a level 400 or 300, which is the terminology we use at Microsoft to determine the depth of the content from 100 to 400, from least deep to more deep, least technical to most technical. But we're very happy to give you that content. So feel free and take a look at that, aka.ms/AKS/content survey, and tell us what you want. We're happy to post videos for it. We're happy to do sessions and events like these and cover those in depth for all the topics you want, either things that we're covering today that we might not go as deep as you want, things that we're not covering, things that you saw on that wheel, things that you didn't, anything. Just let us know what you want. We're very happy to kind of assist with that. All right. So hopefully everybody got all the links, got all the giant QR codes. Let's jump into the topics. So the first one is proactive workload resiliency. And why do you even care? So it's probably kind of obvious. Outages cost time and money. Also, time is money. So outages are money squared. So that's a lot of money. And that should kind of be self-clarifying. We don't want to have outages. We don't want to spend that time. We don't want to lose that money, lose that customer, lose that business. One frame, one context, and this is also something for you to challenge in our reliabilities and resiliency tables as well, for all of you that have been using AKS, is in the study that we asked Forrester to run anonymously with a lot of our users, they have reported to have a 65% decrease in the number, the severity, and the duration of outages after adopting AKS. As I mentioned before, this is unlikely to be a sole factor of just like getting some things containerized, thrown into a Kubernetes cluster, outages reduced. There's likely processes involved, adoption of CI/CD, more DevOps methodologies. All of that, of course, makes a big part of it. But also ensuring that you have a platform that has all the three areas. And of course, there's a lot more areas in resiliency, but once again, we need to be very focused today. And this is kind of how we think a lot about that proactive workload assurance. How we are doing it in the service, how our platform itself is reliable, how we're offering you controls and helping you with the resilience of your workloads, and then how we're basically making upgrades smooth and unimpactful for you. These are three of the main areas that we've both been investing and are going to continue to invest on a lot. So let's start to take a look at some of them. Pavnit, do you want to jump in a bit and have us talk about this? So in terms of platform reliability and scalability, I really like that you at least got the dress code right. That was a very good one.
I was talking to you last night.
Very good, very good. Nate, we got the mic somewhere? Did you stole it? You stole it. We got to go back for it. And in the meantime, as Pavnit kind of comes back up, we've been doing a lot in terms of AKS reliability, in terms of the platform. Of course, you might already know the control plane autoscales. Everything that we do is managed. Add-ons are also part of our responsibility to do. We try to manage and do as many operations as we can for you. So can you tell us a little bit about what have we been doing? I mean, it seems great. What have we been doing on top of this?
Yeah, so it's really about how can we get you going from day one, right? From out of the box. So we've been working, some of you already know Prometheus is not necessarily the most scalable metric store. We've actually been investing heavily in making Prometheus reliability improvements so that you get your metrics even at a large node scale, think 2,000 plus nodes. Or we've been working with all of Azure Compute to really redefine how our API throttling works so that you get greater scale with AKS within your subscription and region. Now, I don't know if you've used AKS for a while, but today we can actually run up to 100 clusters within a single subscription and region, and we're going to continue to push those boundaries so that you get greater resiliency and less throttling and less scale issues.
So that was not always true, right? Like there was times where we recommended things like 20 clusters, sometimes even less than that. So what changed?
So what we realized was that the way the compute APIs were working was not really optimized for cluster autoscaler and the Kubernetes platform, right? So we went back to the drawing board. We redefined how we do API limits. Now API limits are based on per resource, so per VM or per VMSS rather than a large subscription level API bucket. I'm talking only about compute right now, right? So we redefined that. Then we actually took that redefined algorithm and doubled the limit for AKS because we wanted to ensure that AKS customers are not hitting API throttling.
Very good. And the other part, so that's the Azure API. So when I scale, when I upgrade, when cluster autoscaler or Carpenter, there's things. There's also the control plane side of the house, right? The API server. And that can also be throttled, right?
Yeah.
So what have we been doing in there to solve that?
So we've been, again, going back to the drawing board, right? We've been thinking, okay, how do we improve scalability? Initially, we were pushing towards greater scale numbers. So if you remember 2 years ago, you could only scale up to 1,000 nodes in an AKS cluster. We pushed that limit to 5,000. Then we started thinking about, okay, now how do I make that experience more resilient at a large scale, right? So thinking about tail API server latency. When you make a large list call, how do we reduce that latency so that your operators are not timing out? Then how do we reduce the error rates, right? So that you're not seeing blips where you're not able to connect to your API server, where your operators are saying provisioning, high failure rate. So that's ongoing work. We've already made order of magnitude improvements in the last few months, and it's going to be a focus for us over the next 3-4 months as well, where we'll see 10x to 100x improvements.
To clarify one thing for me, so when I look at those numbers and I see, for example, 200,000 pods per cluster, does that mean at 200,001 the cluster falls over?
Exactly, that's a very good point. So the Kubernetes scale is a multi-dimensional scale limit, right? The control plane. What that means is when you pull along a specific dimension, the scale envelope shrinks across others. So if you're running 220,000 pods, it might actually work. It should work. But it depends on what else is running in your cluster and how are your operators optimized to be good citizens for the control plane. Are they using chunks? Are they using informer classes, right? Are you using daemon sets that are making large list calls for all the pods in your cluster? Then you're definitely going to run into issue in any control plane environment.
So what do these numbers mean then? What do these numbers, these documented limits, what do they mean from us?
Yeah. So we wanted to give some assurances, right? So the upstream Kubernetes really uses cluster loader 2 as the standard for testing control plane. These are tested limits that we were able to run and reproduce, where we were able to run 200,000 pods on a 5,000 node cluster and say, with cluster loader 2, hey, are we able to handle this scale, right? Now, we're continuing to evolve the sophistication of those tests, where we want to add different dimensions and make this list longer so that you have better guidance around CRDs, around watches. And as we do that, you'll start seeing this table become more complex, but also better guidance for you to think about, okay, what are the limits within which I can fly safe?
Wonderful. And so can you walk us a bit into what can we do to make the platform even more reliable? Is there stuff that all of us can do to make it more reliable?
Yeah. So it's while we take care of most of things, it's still somewhat a shared responsibility model, right? Because you run your nodes, we don't know what workloads you're running. So you can do a lot. For example, please use AKS standard tier. It comes with greater cluster scalability. It comes with an API server uptime guarantee. Free tier is not really meant for production use case. I'm really hoping that message has gotten through by this point.
Then what is it for then?
So yeah, like there were a few people here who said first time AKS users, right? That's for you. You want to kick the tires, you want to understand the capabilities, you want to understand, okay, what can I do with AKS? What's the user experience going to look like? That's where free tier comes in. We don't put a limit on how many free tier clusters you can run, but please don't use it for production.
Dev environments, stuff like that.
Exactly. Dev environments, your sandbox, your developers want to play around, right? You want to deploy a POC application to see, okay, what's my end environment going to look like? Perfect.
What else?
So the system pools, right? The system pools is where we run the add-ons, the metric servers and the AMA agents and other add-ons that make your functionality happen in an AKS cluster. But it's on you to make sure they're auto-scaling. Please don't use a 4-core add-on for a large cluster, a 4-core system pool for a large cluster with only 2 nodes, right? As your cluster size grows, these add-on components need more resources to be able to work as they're supposed to. So please make sure you're auto-scaling. Make sure that you're picking your size of the nodes appropriately based on the size of your cluster.
So is it safe to say that if I want kind of a system pool, kind of more of a forget it mode, I should basically set it up with like a D4, D8, auto-scale with some decent limits, like up to 10 nodes or something, and then kind of taint it only to have system components, and just then leverage user pools for everything. And even on the user pools, beware of the noisy neighbor problems of your own applications, right? And then use multiple pools and use taints as well appropriately, right?
Yeah, you nailed it. Again, system pools are not meant to be used for your application pods. That's where a bad application or a client can cause noisy neighbor problems on system pools and make things worse for you.
Very good. Thank you so much. Cool.
Just one quick question.
If it's quick, yes.
A little bit about the subscription scaling limits. Can you talk to me a little bit about that? So we run sort of AKS as a service for other people, and because of complications around getting access to new subscriptions and how we control. Right now, I've got a bunch of AKS clusters in one subscription. Can you talk a little bit about why you've got limits on what I can do in one subscription?
Yeah, so really think about AKS as an abstraction on top of all of Azure, right? So what that means is what you can do within a subscription is also constrained by all the APIs under AKS, right? One of the common issues customers used to run into was VMSS API throttling, because your node pool is essentially a VMSS. If you're doing a lot of up and down scale ups using cluster autoscaler very frequently and at high scale points, you can run into throttling, which can slow down or even prevent scale ups. Now we solved that problem, but it's not infinite, right? So we said 100 per subscription. You can, if you want more, you can actually deploy in a different region because each region is separated, right?
So it is okay, so I could have maybe more than 100, but like 30 clusters in each of 5 or 6 regions.
Exactly.
Yeah,
Perfect.
so it's important to understand basically the pivots of limits. And so before, we actually have pivots that were very subscription-based. Those aren't necessarily, they varied per service. So maybe networking has some, Compute has some, storage has some. Then they became regional and subscription. And now we're even moving all the way to resource-based. So we're actually introducing, which is kind of some of the things that you're seeing over here in this slide, we're introducing resource-based limits, which is fantastic because you can actually have like a node pool kind of struggling, but then the rest of the cluster is fine. And then of course all the rest of the clusters in that subscription in that region are still fine as well. And so that will allow you to do a lot more of that bundling, but always with the right dimensions there. Thanks.
One more thing I'll just add there. The other thing is, because a lot of times we see customers deploy other components like Argo CD or Prometheus, which is polling for all the nodes using VMSS API. Now, we don't control those clients, so that polling rate can be very unoptimized, and that causes issues as well. That's why we kind of set limits to keep that behavior under check.
I feel like I'm gonna need the Oscars music if you guys have it, like just kick people away from stage eventually.
You didn't play music.
Yeah, we will eventually have a lot of QA, and then we will also have the lunchtime, by the way, for a lot of the deep dives. I'm sure you're gonna have hopefully, a lot of good questions like this one coming up. So next we have, okay, so we talked a bit about what the platform is doing. Then there's also what the platform provides in terms of kind of reliability constraints. And so, of course, part of that is zones and regions, naturally. So number one, leverage zones. We just saw that in the demo before. We also just added what we believe is kind of a better default for the max skew of zones, which actually allows only for an imbalance of 1, where before it was 3. So what that means is if you have multiple pods spread across different nodes in different zones, the maximum imbalance or skew across zones allowed is now 1. So that kind of forces that balancing to be a bit better and to be a bit more consistent and more what you expected. How do you achieve even more 9s? Well, you go to regions, and you can leverage things such as front door or traffic manager in front of your clusters and in front of your architecture to kind of start routing traffic. And everything that you see here is literally copy-pasted from our multi-cluster architecture in our architecture center. So definitely take a look at that. You'll have all of these here, and you also have samples and the ability to deploy this exact architecture. Very common and very used. And one thing that I'd like to call out before we move into resilience is that we do have some sessions on reliability happening throughout KubeCon and throughout the week. So if the lunch is not enough to have some of these discussions, you also want to make sure that on Wednesday in the expo hall, and when you see expo hall here, it means the Microsoft booth in the expo hall, we will have a best practice session specifically for reliability. We will have a session covering OpenTelemetry on Azure, and also on Thursday, we'll have a session on full stack monitoring, which also is a key tenet, of course, of having a reliable infrastructure and resilient as well. So moving on to the next kind of tenet, which is application resiliency, right? And the key first thing that we need to cover is, okay, so the platform provides you all those controls and all those capabilities, such as zones and regions. How do you actually make use of them? And that's kind of important. And the way to make use of them is, you actually saw it in the demo, using topology constraints, using PDBs, ensuring that every pod has requests and limits, ensuring that you have the right affinity and the right node selectors for things, so that you maximize the ability across a single cluster and a single region to have that availability maxed out. But what if you want to go to that second one, right? When you have that architecture where you have multiple clusters and multiple regions. And now we might start to struggle because we might have multiple clusters. So, and Lichan, maybe you can come out here so I can ask you some questions as well. We have Fleet Manager, Azure Kubernetes Fleet Manager, to help you out with achieving geo-resiliency across regions. And the way that that works is in Fleet, you have a hub, which is kind of a Kubernetes of Kubernetes, if you want, that can deploy and control deployments across clusters wherever they are, different subscriptions, different regions, anywhere. And what you see here is an example that you'll find very familiar to the one I just showed you, which is max Q1, topology key, and then when inside this file. This is exactly the same thing you would use in a zone type as well, with the exact same names, except your key here is a region, and you're using a placement type pick n, which as the name indicates, you pick n, where n is a number, and then you select 2 clusters out of those. So what exactly is the outcome of this? I suspect that we're going to be placing this application in 2 clusters across 2 regions, right?
Yeah, that's right. We also
Just before
guarantee
you get into the conversation, I just want to. I know there's a lot of people standing in the room, so I just want to make sure that we have all the seats filled. If anyone has an open seat next to them, can you raise your hand? And then if anyone is waiting,
Seats in the front mostly. Come near me. Come.
okay.
We'll have stickers later on.
Yeah, please come fill the seats. Okay, thank you. Yeah, please continue.
So this one will allow you to basically spread things across multiple clusters and wherever they are. So it'd be different regions or different subscriptions. And do we always need a hub for Fleet in these cases?
Yes, that's right. So the hub is the central place where we store the spec of your multi-cluster workload. Then those workload can be easily replicated to the member clusters from the hub.
Very good. And I wonder if this is the only thing that it can do, and very much no is the answer. So there's actually a lot of, I would call it AI dark magic that the placement can do, all the way up to selecting a region that has the lowest per CPU cost for your workload. So again, I promise you I'm not going to talk a lot about cost, but I need to at least bring you up to the Ignite session next week, because I think you really will like it into a lot of the things that we'll have there. So you can very easily leverage Fleet to not only select BCDR scenarios, but also cost scenarios, availability, and much, much more. So we're going to have a lot of Fleet sessions throughout KubeCon, right? So I definitely want to recommend that you folks attend, again, Expo Hall on Friday on Gateway API, which is going to be very key for multi-cluster networking scenarios. Enhancing application resiliency, exactly what you just saw really quickly, but in a full session with Fleet Manager also on Friday. On Thursday, in the level 1, 2 sessions on room 155B and E, which is the one inventory session, and the multi-cluster kind of networking 101, 2 very, very cool ones. And then on Wednesday, which is, of course, this is flipped, so from Friday to Wednesday. Tomorrow, you already had the SIG multi-cluster intro and deep dive. But before I just finish with the sessions, I think we want to at least tease something new, right? And so why don't you talk to us about what we're announcing here?
So this is a new feature we are currently launching. Basically, we want to make like workload resilient to region failures. Like with our integration with Azure Traffic Manager, that means you already can use the placement spec to place a workload to selected member clusters. You can easily change that spec, say to move your workload from one region to another. But while you move that, like you will wonder, like, oh, how do I manage the incoming traffic to that workload since you have changed where they're deployed? So that's why we introduced Azure Traffic Manager like controllers. Basically, we will automatically program Azure Traffic Manager to route traffic to the new workload deployed in a new cluster or in a new region. Then if you like also take away a workload from a given region or given cluster, it will also remove that one as a backend of Azure Traffic Manager. With that, like basically, you are no longer worried about the failure of a single cluster or a single region. When that happens, just remove the workload, move the workload to a different region or a different cluster. We will take care of the Azure Traffic Manager to automatically route incoming traffic to the right location.
Very good. And it also simplifies all the setup, right? Because in the past, you have the very easy pick N that I just showed before, where you could easily deploy across regions and maintain that. But then you had to set up that front door traffic manager yourself. But now you can deploy that together with your resources, with just this additional resource, and that will set up and configure those routes for you and achieve that active-active, archi-passive for you, right?
That's
Very,
right.
very cool. So there's a lot of additional announcements that I didn't show here, but there will be in a Ryan session in the hall that you'll see from, how do PDBs work across clusters and regions and things like that I definitely recommend a lot of you to check in. So thanks, Lichan. And I would also like to invite the folks from Azure Storage to come in on stage. So Jeff and Francis, who work respectively on Azure, who did I say, Jeff and Francis, so respectively work on files and Azure Container Storage, to come on stage and talk a little bit about how Azure is kind of helping and simplifying kind of state management, which is a key component of persistence, which is a key component of resilience as well. Come on up. And I would love to understand first, I don't know who wants to take on the mic first, kind of what are the storage options that we have in Azure and how can they help users in this kind of resilience scenarios?
Yeah, so as most of you know, we have a lot of different storage options for AKS. If you have a read once workload, we recommend block storage, and so that's Azure Disk, ESAN, local NVMe drives, and then if you have persistent volumes that need to be accessed by multiple nodes, we have shared options like Azure Files, Azure NetApp Files, and Azure Blobs. And not only do we provide these, all these different storage options, we're also investing in key capabilities for these options, like zone redundancy to increase availability, and snapshots for data protection, and enhance security options like private endpoints to restrict access to storage endpoints, and bring your own key for encryption at rest.
Very cool. So one question that I always had is, so SAN stands for storage area network, right?
Yes,
so it's
that's
kind of
correct.
network attached storage still, and it's block based, right?
Yes.
What's the difference from Azure Disk?
Yeah, that's really a good question. So Azure Disk, we have better story with ElasticSAN, basically trying to have a kind of very ESAN. You can create so many PVs out of the ESAN. So which is something we're trying to improve, which is core benefits of Kubernetes, right? People trying to have like thousands of pods running on top of AKS cluster without kind of noticeable latency, etc. So we have kind of very great improvements regarding scaling. We are increasing like 1,000 pods within 1 minute and 3,000 pods within 3 minutes. That's something we're trying to get the best performance to support workload scaling.
Very cool. Thanks for that. And so in this kind of trend of resiliency and persistence, how can Azure Container Storage kind of help with AZ awareness and spreading workloads across? How do these storage pools kind of work across these zones and zone awareness?
Yeah, I think the failure is really something we're trying to get out of the mission, especially for mission critical workloads. So basically with zonal awareness, with Azure Container Storage, we basically have two options. Basically, if VMSS is having each node in different with zone, so you can basically create one type of zonal storage pool with one LS in each zone. Second option, you can create a 3 ZS disk, and which is have the service layer replication, out of the application replication, which with LS options, basically your application need to replicate data across different zones. So whenever outage is happening in one zone, application replication can cover the story. But with ZS disk supported storage pool, it's automatically supported with Azure Container Storage. The disk pool will be automatically attached from another availability zone. So this could be something you can take better care of with the service side.
Awesome. So I definitely love kind of the automatic recovery in case of zone failure, because that's a big problem. When you think of resiliency and state, it's kind of usually one of the big issues. So I don't know how you want to split this out, but how can you tell us a bit about some of the things that you've been working on and some of your recent updates and some of the things that you've been going to launch soon, hopefully?
Yeah, so before we get into the recent updates and roadmap, I did want to mention that, at Ignite next week, we're covering the full list. So this is just a list of the key investments for each storage service. But just to highlight, some of the improvements we've made recently. So Azure Container Storage, is now GA for both elastic disks and ephemeral disks. Azure Container Storage helps with volume management. And then for Azure disks, we now have live resize for premium SSD and ultra disks. So, if you provision a certain size and you want to increase that size, we now support that for those options. For Azure Files, we've had a pay-as-you-go model for standard file shares for ever since we introduced it. And one question we get asked from customers is help me estimate my cost, because the total cost is based on how much data you're storing in your file share, as well as your transaction cost, right? So we always get this question, well, how many transactions we got to generate? And that's really difficult to estimate. So we just announced 2 weeks ago a new provision model for standard file shares. And we're currently deploying this in all the regions. But with this provision model, you choose the capacity, IOPS, and throughput for the share. And you know up front when you provision that share what the monthly cost is going to be. So you get cost predictability. Some other benefits you get is you get per share metrics. So we never had that for standard file shares, and we're adding that. And then we're also increasing the scale to 256 terabytes. So Azure file shares have been limited to 100 terabytes. And then moving to Azure NetApp files. So with NetApp files, one common feedback that we hear from customers is the minimum capacity pool that is supported is 2 terabytes. And so we've reduced that to 1 terabyte. And we've also reduced the minimum volume size that we support from 100 gigs to 50 gigs.
Very good.
All right, so moving to the roadmap. So container storage currently supports Elastic SAN, but it's in preview. So we'll GA that soon. And then for Azure disks, there's this feature called Performance Plus where you can enable it on the disk, and it's going to get you higher IOPS and throughput. And this is for premium SSD, standard SSD, and standard HDD.
So how much is that going to cost me?
There's no cost to enable this.
I can just enable it?
Yeah, you can just enable it.
Love it.
Yeah. And then moving to Azure Files. So the metadata caching feature, I'm going to talk about that a little bit later on, so I won't cover that right now. But the next item in the list, and we've heard this feedback from AKS customers is hey, I want to use premium file shares, but your minimum volume size is 100 gigs. So we're reducing that to 32 gigs. And then for NFS, we've supported NFS for a couple of years now, and we've been working on adding all the capabilities around data protection, and now we're focusing on the security improvements. So we'll have encryption in transit in preview soon. Okay. And then moving to NetApp files, as I mentioned, they will GA the 50 gig minimum volume size.
Very good. Thank you so much, folks. So I want to kind of not finish kind of the stateful piece without talking a bit about backup as well. I can start taking these from you. Thank you. And you might have already seen demos from backup before. Again, we have it on the last KubeCon. By the way, Nate, do you want one of these? And you already have one? Fantastic. I have 2 now. And Azure Backup for AKS is, thank you, sir. Continue add value. Is a fantastic feature if you want to basically do application level backups, if you want to backup persistent volumes, if you want to backup full clusters and full etcds, and whether you want to restore to a different cluster in the same region and same subscription, or different subscriptions with different RPO needs across the board as well. Now, one of the things that have been a big ask and that we demoed on the last KubeCon in Europe, in Paris, was the ability to restore across different regions, which is obviously a key ask when you're doing resiliency and you want to get that recovery. And so Azure Backup actually now supports that, and we preview that and is GAing that next week at Ignite, as well with several other capabilities such as offsite backups, ransomware protection, and a lot more. So definitely tune into the backup session at Ignite next week to know a lot about all the goodness that Azure Backup for AKS has been creating, and things such as soft delete, immutability, different authorization capabilities, and granular RBAC have been a lot of the key things that they've been doing there. One other ask that we've got a lot is, since also Jeff was just here, is backup support for Azure Files. And that's also something that we're working on, and it's coming over 2025. So definitely something that is going to come and that we're working on right now, both Jeff's team and the Azure Backup team. You already saw chaos testing. So just kind of a recap. If you want to have a resilient system, you definitely want to test for it, whether you're doing it yourself or you're using chaos testing. Again, chaos testing leverages chaos mesh. You can also use chaos mesh yourself. You can leverage all kinds of fault experiments within Kubernetes. You can also mix that in Chaos Studio with infrastructure experiments that mix Azure networking with Azure Compute and Azure Storage as well. So you can simulate all kinds of either in-cluster or out-of-cluster situations to see how resilient your environment actually is. Test things like failover, things like Lee Chen was mentioning before, like are you actually able to, is the traffic manager configuration actually working appropriately as you expect, and all the different scenarios and situations there. All right, so upgrades. The last triad of that workload resiliency piece. So usually the struggle is reconciling these kind of three areas, which is staying within supported Kubernetes versions, ensuring that your upgrades are progressing, they're successful, and they're finishing, and you're able to move to a different cluster, you're able to actually finish that version and move to the next one, and at the same time also ensure that your workload is not impacted, that there's no disruptions and there's no issues. And this, again, triad is kind of an issue across the board, because either there's misconfiguration of PDBs, like over 70% of all our cluster cancellations, of the upgrades that get canceled automatically by AKS as a platform, are because of a misconfigured PDB. And by the way, the remaining of that, all the way into the 99s, 999s, are still typically about some form of what we call a user error. No excuses on us there. We're doing a lot of work, as I'm going to share here, to reduce that and to improve that, to give you more visibility, to give you more control, and to automate that further, like the API breaking change detection. But it is to kind of say that it is preventable in, again, 99.99999 of those cases. The other case is just no availability constraints, which is my favorite. Is there is a PDB, but there's no probes. That's my absolute favorite, which is the case of the ghost PDB, which is a PDB that does nothing because there's no probes. And so it has no idea actually if the pod is ready or not ready. And so it's kind of like, cool, you have a PDB. Or there's just no PDBs whatsoever. It's not a misconfiguration, they're just not there at all, or there's no high availability. So just a flat out kind of availability constraint misconfiguration, also very common. Breaking changes, we talked about it, not gonna dwell there a lot. This used to be one of the biggest areas of issue for us. This obviously, since the release and GA of those features after 1.26, has dropped down dramatically on folks using AKS Upgrade. The other is just the time. It's just too long sometimes to just do the upgrades across different clusters, very large clusters. I have 5,000 nodes. I'm using a max surge of 1. It goes one by one. It just takes a very, very long time to get that upgrade done. Heck, it can take many, many hours, even days, if I have a 5,000 node cluster. And then it can get cumbersome because I have not only one cluster, I have multiple environments. I might want my test done first, or my dev done first, test second, and then production. And then this starts to go into the weeks and into very complex, kind of almost pipeline-y like situations. And finally, it's the heterogeneous area of it. I already mentioned, I think I heard AKS as a service. We might actually have to steal that name. But then there's other things like platforms on top of AKS to provide that to different developers across the company, shared clusters, and the skills might vary. So you might have all of this in the same cluster from different teams. And you might have teams that have a lot of skills, teams that might not, and how do you handle that? All right, so hopefully that's clear on the why. Now what are we doing about it? So the first thing, we've been doing a lot about it, of course, with API breaking change detection and the announcement of a lot of controls. But one of the key things that we're adding right now is a revamp on our upgrade algorithm. Up until now, the way that the upgrade operation works is very, very conservative, and essentially we'll start node by node, and the moment that one node fails, it will just stop. So you can go, fix that node, and then continue that upgrade. Now, if you're using kind of a max surge of 1, that's basically the same behavior you're going to get today. However, if you use our default of 10% or 33% or 100% or anything that is not just a 1 node in max surge, you actually can benefit from the continuation behavior, which is as long as you have nodes that can allow you to serve as buffer and continue that upgrade safely, we're going to continue the upgrade. So if one node gets stuck in draining and evicting all the pods there because maybe one has a bad PDB, we're going to continue until we end up of space to finish that upgrade. So you might end up with a cluster of 10 nodes where one node was not drained, but we arrive at the end of the whole 10 nodes versus stopping, let's say, at the second node because that node failed to drain. That's already there. You can already benefit from that today. The second thing is a new undrainable node behavior, which is what if, like in cases where you have these heterogeneous clusters or maybe you're doing upgrades on behalf of different teams, you might want to have some visibility and control over when those undrained cases happen to make it very easy for you to reach out to the right team so they can fix the applications or manually evict them and then finish the upgrade. So you can kind of marry this continuation behavior with a better visibility. So this new undrainable node behavior allows you to, instead of what happens today, which is those nodes just stay there as they were in the old version. So you end up, let's say, with the 10 nodes, 9 nodes upgraded, 9 out of 10 upgraded in 1.30, and 1 node still in 129 and running. You actually are able to set it to cordoned right now, and it will become unschedulable. So yes, it's still there, it's still in 129, the application is still running, but no new applications are going to land in that node, and it's labeled as quarantine with the label that you see there, which is the upgrade status quarantine. So now you're able to very easily query, maybe it's 1 node, maybe it's 5 nodes, maybe it's 10 nodes, it depends on how big your cluster is, and you can very easily query which nodes are stuck, and you can then go into the teams that own the application stuck in those nodes and work with them to get it done. And what do you do after those are evicted? Well, there's really a number of options for you. You can either restart the upgrade after they're correctly, the PDBs are corrected, or the applications are evicted, or the probes are corrected, whatever was the issue. And you can restart the upgrade, and we will run on those nodes that don't match the desired state, we'll run it again. Or you can just manually go and evict the pods into the existing upgraded nodes, and then delete that node, just like nuke it yourself using the machine API or the node delete API that AKS provides as well. And so in that case, you had just one application. You already had 11 nodes at the end of the upgrade, so you can just nuke one of them and stay back with 10 again. So when you add this app into a lot of the things that we've been shipping over the last year, you can really set yourself and set your clusters up for really, really smooth upgrades. By yes, leveraging auto upgrade. We still get some questions on this, but who's really using auto upgrade? We have now I've passed over 50% of all clusters in AKS are using automatic upgrade. So this has moved on from the minority being this very edgy minority using auto upgrade to actually the majority using auto upgrade. Yeah.
I have all my non-prod clusters auto upgrade. How are you saying we're getting good to do this on my production?
Yeah, a lot of for example, all our internal teams are required to do that on all their clusters. And the way to do that is really the key. So doing auto upgrade randomly, I wouldn't call that okay. But that's why we have things like upgrade schedule, which is triggering an upgrade schedule in the same day that you run it manually should be, at the end of the day, the same result. Now wait, but I also want to run my tests first and confirm that they're upgraded before my production gets hit. Good question, let's park that for a second. I'll get there in a bit. What about the heterogeneous problem, where hopefully you can use this new behavior to achieve that? What about our colleagues from Teams? They gave us very interesting feedback where essentially their problem was that they're media, right? So they're calls. And the typical timeout of a node to drain fully is 30 minutes. Now for most applications, that's fine. A pod to evict taking 30 minutes, that's kind of fine. But if you're using all the best practices where you're using pre-stop hooks and termination grace periods and all of that, in a call, what they do is they wait for the call to finish, which is kind of, if any team users are here, I bet that that's kind of what you expect and not just random drops when they're upgrading a cluster. However, what are the typical times for calls? 30 minutes, 1 hour. So that immediately hits the timeout. So they asked us years back, can we customize that timeout? And we said, yep. So we provided node drain timeout customization that you can configure per node pool. What exactly is your timeout time all the way to 24 hours? If you have a call over 24 hours, you have other problems. Something else you need to solve. What if you have clusters that you have legacy applications and things that are really not cloud native? You can't use PDBs and probes effectively. We have some users like that as well. So how can you mix and match? So we have node soak time. It's not really a best practice because the best practice is to use PDBs and probes. But if you can't, the next best thing is to actually wait between each node upgrade during the upgrade so that there's time for the applications to spin up and for the other ones to scale down. So that's what that soak time adds. And it can add additional buffer time if you need it as well. And if you have monitoring that you want to control and look at and be alerted for as well. And then of course, on most of the left-hand side, you want to make sure that all your deployments have all those best practices. So before you go in and you do that in, say, your production clusters, you definitely want to make sure that you run it manually several times, which I'm sure you have, and that all your applications there, you're making use of all of these from a deployment perspective as well as from an infrastructure perspective. However, there's one last thing, which I asked you to hate, which is, but how do I do then safe and progressive rollout? Which is, how do I make sure that I start on my dev and test? So as you mentioned it very well, there's almost no reason to not have your dev and testing out to upgrade. That's a very easy to adopt behavior. How do you go then from there into production, which is a much more risky piece? And the way that we normally recommend is to use upgrade runs, which is let your clusters, as you have in dev and test, become a stage of a fleet upgrade run, where you can make your group test one, your stage test, your stage dev. Then you can even have groups which can become essentially regions within that. And you can make your different kind of rings as well for your upgrade. And then you have wait times between them. So you can have your dev and test kick off automatically at the upgrade schedule that you prefer. And then you wait there manually. And then you need to approve for it to go to production. So that's the safest way that I would recommend to actually enable that kind of behavior. Because now, you not only are putting them in a sequence, but you're also guaranteeing consistency. Not yourself by timing things and when new releases and new versions and patches, etc. come in, but Fleet does that for you. So whatever that first cluster there, cluster 01, starts with, then cluster 08 ends with. That's also very, very important because then you don't need to go back at the beginning and start upgrading again to make sure that you end with the same. So Fleet takes care of that for you. And then from here, the natural ask is, but can it start automatically? And now, yes, it absolutely can. So you can set up these upgrade runs to trigger automatically now. So you have your dev and test kickoff automatically first, progress to maybe the next environment, maybe QA, and maybe there you put kind of a manual wait before it goes to prod, and then you approve it, and then the prod sections and stages go beyond that. So all the same best practices from before apply and are there. So what if you have a scenario where your cluster detects a breaking change? It will stop the same way that you just saw in that demo as well. And it will show as failed. And it won't continue. So if any cluster at any point does not complete the upgrade, that counts as a failure, and it doesn't move to the next stage automatically, even if you have the automatic wait times. So this is what the fleet runs give you, so you can start to slowly move into a automatic production level of upgrades as well.